Hi, I'm Joan Cartan Hansen, and welcome to Science Trek, the web show. And answering your questions about simple machines are John Gardner from Boise State University and Catherine Devine from the College of Idaho. Thank you both for being here.
Thanks for having us.
It's great to be here.
Okay, let's go to your questions.
Hi, my name is Rachel. I'm from Basin Elementary School. My question is, why do we have simple machines?
We have simple machines because we as humans were smart enough to figure out how to do them. They weren't given to us, they weren't discovered, we invented them. And we invented them because we had things that we had to do, things we wanted to do that required more force or more pushing or pulling than we were capable of doing as humans ourselves. So these machines are ways of multiplying our own effort and to get a difficult job done.
My name is Myra, and I go to Garfield Elementary. And my question is, why doesn't homework or thinking count as actual work in a science kind of way?
That's a great question, because most of you know probably thinking or work can actually make you feel physically tired. So work from a physics professor standpoint, I'm a physics professor, so we think about work as force multiplied over a distance. And so thinking and when you're doing homework and you're thinking, you're not actually applying a push or a pull over any distance. And so that's why physicists don't think of homework or brain power as actual work. A biologist or a psychologist might argue that, though, and say that there is actually energy being transformed and burned when you think, and that there is some work there. So to a physicist, I say, no, there isn't any work being done there because you're not doing a push or a pull across a distance. But a biologist might argue that you actually are burning off energy and that does take some actual amount of work measured by energy.
You know, that's a great answer. If I could just add one more thing to that. Part of what we learn in science is that we have to be very careful about the words we use. Words means very, very specific things to scientists and to engineers and other professions. And work is one of those words that means a lot of things to us as in the common language. Scientists will sometimes use common words like work, but they have a very special meaning for them. So that's part of the confusion we have as science teachers and people who educate, is to try to help people understand that there's words that have very common meanings, but in a context or when you're talking about science, they mean something very specific.
Stella asks, what is the strongest simple machine?
I think the short answer to that is it depends. It depends on what you mean by strongest. There's many different ways to think about that. Off the top of my head, I think it's maybe another way to ask the question is, what's the machine that can exert the largest force? And again, there's not an easy answer to that because they can all be designed to exert very large forces, to multiply our forces in a certain way and in a very large way. So they all have their strengths. There isn't one that you can say is better than the others.
My name is Christian, and I go to Garfield Elementary. And my question is, who decided that there are only 6 simple machines?
Well, the ancient Greeks actually were the ones that first started giving the terms like machines, like this, the pulley is a simple machine or the wedge is a simple machine. And so I think it was Archimedes around 10th century BC was one of the first to kind of narrow it down to a pool. And then later on, during the Renaissance scientists started kind of classifying types of tools as simple machines. And I think that it was in the Renaissance that we wound up with the 6 that we call the 6 simple machines.
Dagan would like to know, how can a pulley help us with our jobs?
Well, a pulley is a simple machine that often used for lifting things. And it's if you have an object like a heavy sack of cement or a big bicycle or something like that, and it's too heavy for you to lift just by picking it up. A pulley system can be hung from the ceiling and used to multiply your force, the force that you're able to produce to counteract the weight of a heavy object and pick it up.
Hi, my name is Brent. I go to Garfield Elementary School. My question is, why was measuring work named after Newton?
So the unit of work is actually called a joule, or it's measured in energy. Newtons measure force. So imagine a force as just simply a push or a pull, right? And so those are measured in newtons, and they're named after Newton because he was one of the first people to come up with some of the Newton's laws, which are laws that measure or kind of talk about force. But work is slightly different than force. Work is force measured over a distance. So if work is in a push or a pull, if force is in a push or a pull, then work is measured in how, over the distance, how far you push or pull that object. And so that actually is measured in units of joules, which quantify energy.
And if I'm not mistaken, 1 joule is 1 Newton meter.
Yes.
So, one force of Newton applied through a meter is equal to 1 joule.
Deborah asks, why were simple machines invented?
I think simple machines were invented by the people who had a specific need to fill. And so if you had a lot of heavy stuff that you needed to get from one place to another, that would be a good reason to invent the wheel, to make it easier to roll that stuff across the ground. If you had to lift, like for the people who were building the pyramids, for example, they used a lot of ramps and wheels in order to lift these huge heavy blocks to build these huge monuments out of very, very heavy stone. Wedges were used to split apart wood and for building material. And so I think a lot of these simple machines were built by various cultures at various times, and often they were invented kind of independently by many different people to fill a very immediate need.
My name is Blake, and I go to Dalton Elementary School. And my question is, what types of levers do you use, and what types of different things take hydraulics?
So those are two very different questions. So I think we use levers all the time, and it's a little hard to see them sometimes. Taking the analogy of a bicycle, I think you could state that the steering, your handlebars are kind of a lever. You're exerting forces at some distance away from the middle of the bicycle to make it rotate around a smaller distance in the middle, and gives you better control. Hydraulics is a more complicated set of machines, and they're using fluid, water or oil, to do something very similar to what levers do, exert a force at a distance and change the nature of the force. Probably the most common use of hydraulics is in brakes of your automobile, or in some of the newer mountain bikes use hydraulics. So you can exert force on your handlebars, on the brake levers, or on your brake pedal in your car, and the hydraulics, the pipe that moves the fluid around, exerts force on brake pads that grab the wheel and make it stop.
Hi, my name is Aaron, and I go to Garfield Elementary. My question is, are some simple machines used more than others?
Yeah, I think that some of them are, just because some of the machines are a little bit more broadly applicable. Like, they have a lot of different ways of using them versus some of them are more specific. And so, for example, wheels and axles and levers are used in all sorts of machines, or other more complicated things, and have, you get, like, again, back to the bicycle, it uses wheels and levers. Things like screws are a little bit more specific to a purpose, and so I think those are not used in as many different ways as a wheel and a lever might be. So I think that there are some that get used more often than others just because they have more applications.
I'm sorry, but we've run out of time. Thanks to John and Catherine for answering questions.
Thank you so much for having us.
It's great to be here.
And thanks to the folks here at the Discovery Center of Idaho for hosting us. If you want to learn more about simple machines, go to the Simple Machines area on the Science Trek website. You'll find facts, links, games, our Simple Machines broadcast show, and lots more. And every week, check out my blog for the latest science news for kids, all at idahoptv.org. Thanks for joining us. We'll see you next time on Science Trek, the Web Show.